Voltage drop. What is the meaning of voltage drop? It's how much the voltage decrease in a segment of a conductor. Why? Probably because of the load is too heavy, the consumption of amps in the load is too much, and the voltage decrease from this point into this point. For that reason, when you hear about the voltage drop, it's in between 2 points. How much is the voltage drop across the terminals A and B? How much is the voltage drop at the solenoid of the start motor during the cranking? How much is the voltage drop in the output of the solenoid? How much is the, it's in between 2 points of reference. How much is the voltage drop in between A and B? As current flows through the wire, the voltage drop is according with the ohm law. Alright, if the power supplied on the circuit is 12 volts in the battery, and the voltage drop 0.5 volts in the positive conductors and 0.5 volts in the negative conductor, then the voltage across the load is 12 minus 0.5 and minus 0.5. In other words, the voltage drop is 1 volt and the final voltage will be 11 volts. In total, the voltage drop in this particular case is 1 volt. How much is the total voltage drop in percentage? Oh, is 1 volt divided by 12. This is 8.3%. Simple. Okay. In the future, I need that you memorize those numbers that I am going to give to you in the future. In the future, we are going to consider 2 different types of the voltage drop. We are going to use 3% of voltage drop for what? For panel board, feeds, for bills pump, for blower, for electronic, for navigation. And we are going to use 10% of voltage drop for lighting. In other words, we are going to consider a voltage drop of 10% for lighting. And we are going to consider a voltage drop of 3% for the rest of the systems. That's it. What is the meaning of 3%? It's 3% of if the volt is 12 volts, is 12 times 3%. How much is 12 times 3%? It's 12 times 0.03. And this is 0.36. The voltage drop. How much is the 20% of 80? Is 80 times 0.2. How much is the 30% of 45? 30% of 45. Is 45 times 0.3. I want to remove the 20% of 100. I want to remove the 20% of 100. Is 100 times 0.8, because I am going to remove 20. I am going to add it 20% to 100. Is 100 times 1.2, because I am going to add it 20. Simple, no? Yeah. How much is the 3% of 24 volts? The 3% of 24 volts is 24 times 0.03. Simple. All right. In the future, we are going to use a voltage drop of 10% for lighting. And we are going to use a voltage drop of 3% for the rest of the electrical installations. Ready? Okay. And we are going to use in the future, in order to calculate the area of the gauge in circular mills, we are going to use this formula. The area of the circular mills, the area in circular mills is a constant. The value of the constant is 10.75. This is the constant. Times the intensity in amps and times the total length in feet and divided by the voltage drop. This is the formula. K is the constant, I is the intensity in amps, the total length, remember, is the round trip, and E is the voltage drop. E is the voltage drop. I need that you memorize that formula because in the future you need to use that formula. Oh, the area in circular mills is equal to the constant 10.75 times the total distance back and forward times the intensity in amps and divided by the voltage drop. If the system is in 12 volts, is 12 times the voltage drop, 3% times 0.03. If the system is 24 volts, is 24 times 0.03. Okay, now that value in circular mills, with that value you use this table. I have an example. We are going to follow the example. All right. If the voltage drop is 3%, we are going to use the following formula recommended by ABYC to calculate the size of the gauge of the wire. Okay, the formula said that the area in circular mills should be equal to 10.75 times the intensity times the total length and divided by 3% of 12, 0.36. All right, for example, this is a typical example. I have a bilge pump. The bilge pump, the consumption is 10 amps. This is the intensity, 10 amps. The positive cable runs 10 feet from the power panel, including the flow switch, and the negative other 10 feet. What is the size of the wire? Okay, let me check. The size of the wire is 10.75 times the total intensity, 10 amps, times the total is 10, and 10 is 20. Times 20, and divided by 0.36 because is the installation of a bilge pump. Is 3% of 12. That value is 59.72. If I return to the table, 59.72 is pretty close. Is pretty close to this one. For that reason, I am going to use a cable number 12. You like it? This is simple, and you have the tables in this book. All right. Other important recommendation for ABYC that we are going to use in the future. The minimum gauge of the wires recommended is 16. The minimum gauge recommended for wires is 16. There are exceptions according with ABYC. For sound and speakers and audio, you can use gauge 18, smaller. But the minimum recommended for electrical installation is, according with ABYC, 16. ABYC question. And normally the wires for panels are in between 16 and 10, 8 maximum. All right. And the cranking cable, the battery cables are bigger in bigger numbers, in between 6 until 1 zeros, 2 zeros, 3 zeros, 4 zeros, depending of the intensity. All right, let me explain something. This is the diameter of the wires. The diameter of the wires. And this is the number. The smaller is 18, 16, and the big ones are number 6, number 2, number 0. Okay, when the number increase, the diameter decrease. Yeah, when the number increase, the diameter increase. This is very important. Keep in mind that explanation because we are going to use that explanation in the future in order to calculate the gauge of the wires. But don't forget, the procedure using the formula is using this formula. The formula circular mills is equal to the constant times the intensity divided times the length divided by the voltage drop. And immediately you found that number in circular mills, you go into the table and you select the number approximated with the table, and after that you identify what is the gauge of the cable. This is the procedure using the formula that you have in your book. And the procedure using the table, in the table that you have in the ABYC study guide, you have two tables. One table with a 3% of voltage drop, one for 12 volts, another for 24 volts. Another table with a voltage drop of 10%, one for 12 volts and other for 24 volts, right? To use the table of ABYC, we have on top the length, the total length, back and forward. On the left, in the column, you have the amps, 5 amps, 10, 15, 20, 35, 40, 60, 80, 100. The amps here and the total length over there. I have the total length and I have the amps. This is the gauge of the wire. It's too simple. This table, this is exactly the same table that you have on the screen right now, is for 3% of voltage drop, 12 volts here and 24 in the bottom. And this one is for 10% of voltage drop for 12 volts and 24. Okay, on top you found the distance in feet. In this column, you have the intensity in amps. According with the intensity and the distance, you found the gauge. This table is too simple. There are in the final ABYC study guide in the ABYC exam, like 5 or 6 questions related with the use of these tables. It's not complicated, and you need to be familiarized using the table because we are going to use the calculation of the wire gauge in the future constantly. After that, we are going to talk about the marine grade. The cables, the marine cables should be marine grade, marine approved. And we are going to use always marine grade cables. Never use industrial cables, never use residential cables, because those cables produce excessive resistance and produce corrosion, and those cables are not accepted. And probably if you use those cables, your installation is not approved, and probably you have a complaint, and you need to remove the equipment and do the job again. Be careful with that. All right, and the majority of the marine grade cables, they come in single spools, in duplex cables or triplex cables, and all of them with the stamped labels indicating that is a marine grade cable. Spools of wires are available with insulation colored in different colors to indicate if the cable is the positive cable, the negative cable, and AC cables for American power or AC cable for European power. We are going to learn later in other chapter the color code for those cables. But be careful, use always marine approved cables in order to avoid this situation. This is corrosion. This is no good in your boat. This is the enemy of your boat. For that reason, you need to use all the time marine grade cables, marine approved cables. All right, one important situation that we are going to keep in mind in the future installation is this. In DC installation, we are going to use for positive the color red color, and for negative black. All right, but black have a little inconvenience with respect to the AC power. Let me explain what is the meaning of that. This is for DC. This is for DC. For AC power, you have 3 cables. One black, the hot line, one white for the neutral, and one green for the ground. The problem with the black in 120 AC power is that the people can confuse this black with the black of DC. This is the ground. This is the negative. All right, for that reason, the new installation, they recommend replace the black color for yellow in order to avoid confusion with the hot line in AC. For that reason, the recommendation is today do the installation with red for positive and yellow for negative. Try to replace the black for yellow. This is the recommendation today in order to avoid confusion with the black used in the hot 120 or 240 AC power. Right, for that reason, after 1995, the black was recommended be replaced for yellow in order to avoid that confusion. And right now, I want that you keep in mind this table, because this table will be your Bible in the future. This is the color code that we are going to use in the future for installation. And I want that you refresh and you memorize this table, because in the future you need to keep those colors clear during the installation. When you are working in a console of a boat, you need to keep it clear the concept of the color code in order to avoid confusions and in order to avoid mistakes. All right, the green color for the wires will be used only exclusive for bonding system. Bonding is the connection of all the metallic parts together in one central conductor, and that conductor with the zinc outside. This is the bonding conductor. And we are going to use that bonding conductor green color. Okay, in the future, yellow or black will be used for ground DC. The red will be used in the future for the main power DC. All right, we are going to use the yellow with red for the signal for the start motor, the signal for cranking, for starting system, that the signal to activate the solenoid on the start motor, yellow, red. We are going to talk about those colors in the next coming chapters. Brown with yellow is the color used for the automatic position in bilge pumps. Bilge pumps and blowers use brown with yellow. The color dark gray is used for the signal of the tachometer. The signal of the tachometer, we are going to talk later about that, is dark gray. And also for navigation lights, they use the color gray. I don't recommend gray for navigation lights. In navigation lights, use conventional colors like red and yellow for positive and negative, and avoid use the gray. It's confused. Use the gray exclusive for the signal on the tachometer. Brown will be used for the positive conductors in pumps, the positive conductors in alternators, and in charge lights. In alternators, I don't recommend use brown. I recommend use the color that I am going to explain later during the installation of the alternator. Don't use brown. All right. This is the second page. Orange is the accessory fit. The common fit is the power coming into the DC panel. Normally is in orange color. And other equipment that use orange is the output of the alternator. The alternator produces a DC power in order to charge the batteries. That cable should be orange. That cable is the output of the alternator. The output of the alternator should be in orange color. I am going to explain later. Other color that is, in my opinion, the most important of this book is the purple color. Purple is the color for ignition. When you select ignition position in your ignition switch, the color recommended is purple. All right, and light blue will be the color for the sender, the color for the cable with the signal from the oil pressure sensor into the oil pressure gauge. For oil pressure, the cable with is light blue. The sender in between the temperature sensor and the temperature gauge will be tan. This is the color in between the temperature sensor and the temperature gauge. The color in between the flow fuel sensor and the fuel gauge, the color is pink. And brown, once again, for pumps and general armature. Generator armature. I'm going to explain later that color in specific on the armature of the generators. We have one chapter, chapter 14, dedicated exclusive to generators. 6 episodes related only for generators. All right, my friends, and right now, the color code I explained before, we are going to use for American Power. For American Power, we are going to use the black for hot line. We are going to use the green for ground, and we are going to use the white for neutral. In European Power, we are going to use the brown for hot. We are going to use the blue for neutral, and we are going to use the green with yellow strip for ground. We have one chapter dedicated to talk about those colors in the chapter 9 and the chapter 10, and we are going to talk in details about those colors. Today is only for information. You remember the diagram that I did before about the gauge and the area of the cables? Okay, look, those small diameters, the number is bigger. Bigger number, a small diameter. A small number, 4, 2, 1, zeros, 2 zeros, 3 zeros, the diameter is bigger. Okay, of course, in those big cables, you can move heavy loads. In those small wires, you can move lower loads. Don't forget that explanation. This is a very, very important explanation. Other table that I want that you keep in mind in the future is this table. Is according with the gauge, how much amps you can move. This is important. In the future, for a gauge number 2, you can move 95 amps. For a gauge number 4, 70 amps. For a gauge number 6, 55 amps. For a gauge 16, only 10 amps. For a gauge 14, maximum 15 amps. For a gauge 12, maximum 20 amps. For a gauge 10, 30 amps. I need that you memorize this table. This is your homework. Memorize according with the gauge how many amps. The same like the color codes. Memorize the color codes and memorize according with the gauge how much amps can I move on that cable. This is a very, very important information. This is a very important information. It's more important. This slide is more important. I hope that you remember, try to keep in mind those cables. I explained to you that for battery cables, the cables are going in between number 6 until 4 zeros. 4 zeros is the biggest battery cable for mega yachts, super yachts. They use those cables. The cable usually has a high thin-plated copper strand. The thin-plated copper helps to minimize the corrosion and extend the life of the cable. Typically, those cables are used in installation of DC batteries and DC main powers. This is the duplex cable I explained to you. We are going to use, instead of red with black, we are going to use yellow red because this is the color recommended. In 3+ cable, this is for American Power. For American Power, we are going to use black, green, and white. And for European Power, we are going to use brown, for neutral blue, and for ground green with yellow strip. And we are going to use this equipment, the time domain reflectometer, in order to identify if I have a cable interrupted in some part in between the beginning and the end of the cable. The time domain reflectometer that you have on the screen, and go in one of my video clips. The video clip is electrical measurement tools. In that video clip, I explain the use of all the electrical measurement tools that we need use in the future. The load tester, the time domain reflectometer, the gauge meter, all the equipments electricals are in that video. I recommend that you visit that video and you found all the information related with the use of the multimeter, the clamp, the load tester, the test proof, the megometer, all the electrical measurement tools are on that video, and I explain in details the use of each tool. And the last slide of this chapter is related with this recommendation of ABYC. If you need a rewire a boat, in some cases it's more expensive try to recover the wires, the old wires. In that case, the solution is let abandon those cables, put covers at the end of the cables and abandon that cable and try to pass new cables. Remove all unused wire is not always practical. It's too expensive. The recommendation is let abandon those cables, fold it back, and insulate the ends of the wires in order to avoid confusion, and try to pass new wires in the boat. Okay, this is the end of this chapter, and I hope you enjoyed the chapter. Please visit my website in order to check videos related with the measurement tools and videos related with the connection of batteries and the installation of battery cables. Thank you.